Hello YouTube viewers, welcome to my show Science Thursday. Today we're gonna take a look at induction motor, the backbone of our industrial world. So question comes to the mind, why do we need something like that? Well, we have always used rotational energy, and for that reason we always need something that is cheap, reliable and long lasting. So these are our needs. Who made it? Nikola Tesla. He made two-phase AC motor, and he is also the father of AC electricity. Basically, the entire AC grid is here because of him. So he is the father of it. And then question comes to the mind, how does it work? It's very simple. It has only two parts. One is stator, another is a rotor. How do you know them apart? Basically, stator does remain static, rotor rotates. That's all you have to know. And it works on the principle of induced magnetism. Basically, this outer coil, the electromagnet, has AC current going through it, so it gets energized. Using that energy, it induces a magnetic field. Magnetic field in the rotor induces a current. That current in turn creates a magnetic field, which induces a torque, which basically forces it to twist. Now, if you have single phase motor, you have to have a capacitor to help it start, otherwise it won't rotate, it will just keep vibrating, oscillating. But if you have three phase or even two phase, it has a continuous rotating magnetic field, so you don't need any starter. That's why I said Nikola Tesla made a two-phase motor. And the speed of the motor is directly proportional to the frequency. So if you have something that is running on 50 hertz at the same voltage, it will run differently, versus if you have something that is running at same voltage but 60 hertz, it will run differently. So this part you have to pay attention to. It's frequency dependent. The RPM is directly frequency dependent. So why do we use it? Well, you have to understand there are many types of motor. I can't even list them all. So let's begin with the simplest one, which we call shaded pole motor. It's generally used for very low torque needs, basically running fans, exhaust fan. You will easily find them in microwave inverter, and instead of using capacitor, they have a what's called basically shaded pole. Basically there is a small short coil which creates a sort of phase delay. So because if you have the phase directly going to the rotor, it will just oscillate, creating a lag, sort of gives a rotational energy. Once it starts going, you don't have to worry about it. So this is self-starting, can run for decades, and very simple, very effective. Then we come to one phase home use. This is very common, and they generally employ some form of capacitor or a second winding to help them along. And then we come to the powerhouse, the three phase. Now many of you may find it odd that why do we use three phase. Now the reason we use three phase is not because of voltage, it's because of torque. Now to understand this is a three phase diagram. As you can see, the wave is going up and down, up and down. As long as the wave is up, you're getting useful torque out of your motor, but the moment it goes down, done. Now the reason we don't use two-phase now anymore is if you have to design a generator that gives out that. We generally don't have that. We have three-phase generator. So for that reason, if you have two-phase and you space them out correctly, the problem is the voltage still dips to this point, to 0 volt. So at that stage, and if you stretch a second, when the voltage goes to 0, your motor is not producing any useful torque. So that's why we can't use two. It still has the same problem as single phase. However, when you have three at the degree of 120 degrees, you can easily get three phase overlap. And as you can see, at any time voltage never drops from 0.5. So that's why we use three. Now you might be like, why don't go four? Well, that is true. We do use higher phase motors, but as you can see, we are already at 0.5, and making it 4 will barely push it up a little bit. So 6 phase motors do exist. They are generally used in Formula E, and they give you more torque but don't give you day and night difference. So from single phase motor to three phase motor is a giant jump. Anything more than three phase does not justify the cost. That's why we are limited to three phase. It's perfectly balanced. So uses of induction motors are endless. Basically everything big or small generally has it one way or the another. And the reason for that is because it does not have any brushes. So the rotor works on magnetic induction rather than, there is being a brush that is sending the current into it, which makes it very long lasting. And you might say, well, brushless DLC motor also behaves the same way, and that would be true. However, brushless DLC motor requires magnets, and the magnets are not cheap. Not to mention, they won't last you for decades and decades and decades. They lose power over time. And BLDC motor cannot go very big because the permanent magnet inside would become a hassle to deal with. And that's why diesel locomotives employ motors in their bogies that can easily rate upwards of 2000 horsepower each motor. Generally, we don't go that extreme, but we are generally above 1000 horsepower. And you can see electric car also. You can easily go up to 300 to 500 horsepower, and you can even go to thousands of horsepower. Motor is not an issue. BLDC making it that big is an issue. So, and due to its relative simplicity, and our advancement in inverter technology allows us to control this motor in very unique ways, where we can control torque and RPM independently. And this is the reason why they are still being used in industrial applications, because we can control the RPM and torque. So let's say you are using a grinding wheel, you want to have different speed, like wood will require different grinding, metal will require different grinding speed. So we employ variable frequency drive, where you can change the frequency and the motor will simply adapt to it. So this was my presentation. Hope you guys liked it or learned from it. In that case, please like. If you didn't, dislike, leave a comment, subscribe, because I make video every day. Press the bell icon so you can be notified. And as always, thanks for watching.